Systems and Flowchart in Lecture 1 of Topic 3. Example 2 in the lecture note was about making jam from strawberries. Two methods were discussed. In the first method, strawberry was added and the crushed strawberry exited the system. The system was assumed as a strawberry in the container and we defined a surrounding for that. Suppose the loading of a strawberry happens right at 8 a.m. or sometimes before that. Between 8 and 9 a.m. no strawberry is added. It means that no mass is crossing the boundary. This is a batch process where during the process no mass is crossing the boundary. And as you see for batch process, the amount of feed and product is in quantities like pound mass. However, from 9 a.m. to 11 a.m., when crushed strawberries is being heated and water is removed, the system is semi-batch. The reason is that crushed strawberries as well as the sugar were added at a fixed time, sometimes at 9 or before that, for example, and then between 9 a.m. and 11 a.m. only one stream, which was water, is being withdrawn continuously. And then at 11 a.m. the product jam was removed. So as we see from the four streams, one stream is continuous and the other streams are added or removed at a fixed time. This is called a semi-batch process. And the quantities of the three streams in pound mass, and one stream is continuous, so the quantity should be rate like pound mass per minute. The second method that was discussed was a continuous process where the strawberry and sugar as feed were being added to the system continuously. Suppose that the strawberry, like a semi-liquid, is being pumped into the system and sugar is being added by a conveyor continuously, and then water is obviously being drawn continuously by heating, and jam is being removed as a product continuously as well, like pumping it out of the system in a pipeline. So all the streams are continuous and the quantity, as you see, are in rate, pound mass per minute. It is logical that this process operates at a steady state. It means that the rates are not variable and they keep steady in the morning and in the evening for a length of time, like 10 months in a year, and then the system can be shut down for 2 months in order to have repair maintenance. So this is called a steady state operation. Let's consider the first method and draw the flowchart for that as shown. First of all, there is only one box. The box that we previously saw for crushing the strawberry is not shown here because the change of the shape of the strawberry is not of our interest in calculation, so we don't show it. Therefore, as mentioned in the lecture note, the flowchart of a process is drawn to assist our calculation, and it is not meant to be a picture or physical representation of the process. On the flowchart, the streams are shown as you see and labeled. Based on the assumption in the problem, we want to produce 1 pound of jam, and therefore we have this product as 1 pound mass. The other streams, the amount of strawberry needed, sugar added, and the water withdrawn are unknown in the system, which we show them by the notation M1, M2, and M3. Also, the composition of streams are shown. In the problem, it said that 15% of the strawberry is solid and the rest of it is water. However, in here we show the composition by mass fraction, 0.15 pound mass per pound. We do not show it as percent because when we do calculation and write our equations, 15% has to be converted to mass fraction before being inserted in the equation. On the flowchart, we do not show the things that do not enter directly in the calculations. And that's how we should label a flowchart. Also, as you saw earlier, water was being withdrawn continuously. However, the quantity of it is shown as pound mass because that will facilitate the calculation, and we don't want to have a combination of rate and quantity together in a flowchart. Another thing to note here is that we have assumed that in the system there are three components. One of them is SS, which is the solid strawberry, and we have differentiated with S, which is the solid, as sugar. And then the third component is W, which is water. Alternatively, we could assume only S as solid and W as water, and in that case SS and S would be combined and we would solve the problem as a two-component problem. We will discuss these details later on in a future lecture. When we operate the system continuously, we have a similar chart. Basically, you see the chart has not been changed much, except the flow rates are in pound mass per minute. So these are rates, not quantities. But the compositions are basically the same as before. And the assumption in this problem is the production of jam is 1 pound mass per minute, which is shown here. And M.1, M.2, and M.3 are unknown. When it comes to rate, we can add a dot on it to show that it is per time.